So last class we have been seeing Dirac equation in its perspective, the early attempts. So in today's class we are going to see how we can see the Dirac equation. Before seeing that how Dirac equation accounts, जब हमने psi का लिया था ना function psi, q, s and t, तो we also general formalism of quantum mechanics में we took only space and time as coordinates. When we introduced relatives to quantum mechanics, we also introduced q, s and t, spin beer as a coordinate. So the thing is that how Dirac's theory, Dirac's equation explains a spin of electron, and there is a whole procedure to it. So in the historical attempts, we try to just see कि Dirac ने कैसे achieve किया था. By some hit and trial method, in the sense कि जो second order partial, first order partial differential equation है, इसको second order partial differential equation में convert किया, and जो उसका form उसमें Clifford algebra का use. So we only stated it. So in this today's class, what we are going to see is, for example, we say that this equation, Dirac equation, should be linear in time derivative, and our attempt should be that Hamiltonian is linear in space derivatives as well. So what do you mean that? So we just come to it. तो अगर हमारे पास जो normal equation है, जो if you remember Schrödinger equation, or if you say it's like this, तो इसमें हमारा इसका फॉर्म आएगा ऐसे d psi by dx1 alpha 2 d psi by dx2 alpha 3 d psi by dxp plus beta mc square is equal to hc. If we remember in the previous class, हम at the end where we arrived at, हमारी जो equation की form ऐसे आई थी ना, it came out to be of this form, just like this. And ये तो हमारे पास आई थी ऐसे, it's psi is equal to 0, where this is equal to d by dx of x b, d by dx of x b. So there are both mu's and mu's. ये mu जाएगा 0, 1, 2 and 3. mu जाएगा 0, 1, 2 and if you इसको ऊपर या नीचे करेंगे, the sign change हो जाएगा minus. इसकी वजह से हमारे पास ये आएगा. It's basically what? It's d2 by dt square minus d2 by dx square minus d2 by dy square minus d2 by dx square. You can write it like this also. And if you इसका 0, 0, 0, 1, 0, 2, 0, 3, ठीक है? Actually 16 terms आएंगे. The other 12 terms will not contribute because there will be tensor indices will be different. It will only be dt, same xx, yy, zz, and dt, they only will contribute. And since we are trying to say it's relativistic quantum mechanics, we are incorporating special theoreticity. So ये ऐसे x, y, z, या ct. x1, x2, ठीक है? ये x0 है basically. It's also x0. It's time coordinate. Maybe we are incorporating special relativity. x0 is ct. अब अगर ये है, if you just want to write it, अब ये equation हमने कहाँ से लाई? The point is not they कहाँ से आई. If you assume it like that, if you assume it like that, it will help जो हमारी जो first order derivative and second order derivative वो वाली problem it is assumed to hold. For example, जो हमारे पास coefficients हैं, coefficients alpha I cannot be numbers. ये numbers नहीं हो सकते because they should be invariant under special rotation transformation. Invariant means कोई चीज, for example, you are trying to deal with the spin of the particle, है ना? उसमें rotational sort of rotational invariance होनी चाहिए. In that sense, अगर ये general scalars होंगे, So maybe they will transform here. The rotational invariance will not hold. And जो हमारे पास जो probability function होगा, it will be psi star psi should be conservative. And जो हमारे पास psi है, psi can take any value, psi 1, psi 2, so on and so forth. Then so if it's not any scalar, it has some value here, alpha I and beta I. Alpha and beta are and from and matrices. Alpha means this. You can, so we have, if you remember, जब हमने वो early attempts किए थे, early attempts, if you remember, हमने कहा था these were different matrices, and our argument of how we can convert a second order, first order differential equation into second order, जिसकी वजह से, क्योंकि second order differential equation की वजह से right hand side में plus minus solutions आते हैं, उससे हमको negative probability आती है. Negative probability is not a definite quantity. We don't define mathematically. It's not a positive definite quantity. So in order to convert a positive definite quantity, so we have to convert second order differential into first order differential. So we assume it like that. अब अगर ऐसे है, then and वहाँ पर हमने these were related with different matrices, alpha 1, alpha 2, alpha 3. ठीक है? So in the same way, if we just using the same argument, at c by delta, and this is I is equal to 1 to n. This is alpha 1 divided dx1, alpha 2 divided dx2, alpha 3 now you can see it this way. So this is equivalent. Okay. So now you can say these can be different matrices. Okay. Now question is once we substitute these values in different matrices, does it satisfy this equation or not? That's an exercise which we will try to attempt. ठीक है? That's the result. अब ये इनका form क्या आएगा? इनका form before we are coming to what their form is, we have to as a remember कि जो हमारे पास energy of a particle होगी, energy of जो correct energy हमारे पास ये है. And जो हमारे पास this it should satisfy a clean body equation की form ये हमारे पास है. The original clean body equation, it should satisfy this equation, which is second order differential, which has this form. Okay. So we have a second order differential equation, and we have assumed this equation is this form. ठीक है? अब इस form अगर ये है, then it should satisfy, it should show some sort of equivalence. It should show some sort of equivalence, and that will remove for us the positive positivity condition है ना, it will probability will always come out to be positive in that sense. अब इसको prove करने के लिए we assume in that sense we assume that that it should satisfy a certain algebra. It should satisfy a certain algebra. Algebra means if it satisfies that algebra, this means they are equivalent. This means we can only take positive energy solutions. This means डिराक ने फिर उससे इन्फर किया कि मतलब नेचर चूजेज इट लाइक दैट, नेचर satisfies that algebra. In principle जरूरी नहीं ये algebra ये satisfy करेगा. We are choosing a particular algebra which will have this equivalence between these two equations. ठीक है, this is the argument. You got my point? अब choice of algebra है like this, which you can see in any book, for example. And you can check also alpha j alpha I plus alpha I alpha j one plus I recommend you before coming to this आप कोई बुक है ना जिसे आर्किट की बुक है वो का थोड़ा सा Clifford algebra आप थोड़ा सा उसका rehash what are the properties of Clifford algebra, ठीक है, what have done थोड़ा सा Clifford algebra and जो sigma है ना sigma in terms of polyspin matrices 2 cross 2 matrices है ना, फिर जब हम in terms of 4 cross 4 matrices भी लिख सकते हैं sigma in terms of sigma I sigma, जो ऐसे करते हैं ना sigma I sigma j plus sigma j sigma I है ना, equal to put delta ig. This is some sort of identity which you have at least worked it out, ठीक है. So you have to see, so if you assume this way and if you assume this way, if you make these changes and the algebra ऐसे आएगा alpha I alpha q plus alpha q alpha I alpha I beta plus beta alpha I so you can do it. ये कब आएगा समझ, जैसे लिया था just for a particular example 1 0 0 ये पॉलीमेट्रिसेस है ना, इसी की 4 cross 4 मैट्रिसेस है in terms of sigma, इसका स्क्वायर आप करोगे क्या आएगा 1 आएगा. So in the same way you can choose beta like that, alpha beta alpha I alpha k alpha k alpha I. So these are the set of properties which are satisfied by these. हाँ एक सेकंड मैंने कहा था, एक सेकंड बंद इसको बंद करना. तो ये मैंने so you choose it like that, ठीक है. So if it assumes these properties, so this equation it will come back to the previous equation. That's it. Or in the same way, you can also check other properties. Other properties consider. You can have, for example, you can have commutation properties as well as, so this is, you can have, one is commutator, another is, इसको क्या कहते हैं, this is anti-commutator. Commutator में क्या है, for example, A, B, this is anti-commutator, ठीक है. So you can assume, so you can see this property can be also pulled. trace of BA means क्या diagonal elements का this thing is equal to you can fit into 2 and if alpha and our alpha square beta square ये है it means alpha equal to beta equal to plus minus 1 I get 3 and from this you can have थोड़ा आगे आगे तो डिस्टर्ब हो रहा है थोड़ा आगे चलो डिस्टर्ब काम करो डिस्टर्ब हो रहा है इसी तरह वाला So you can see it's like this trace of B. So if it's plus minus value ये आएगा from this algebra. So this means trace of BA can be, you can show it like this. This means you can another property from this you can just यहाँ से so you can prove this property. If trace of alpha I, so if alpha is beta is plus minus 1. So it's an exercise of if you try at your place. If this holds for these properties and alpha and beta can be written as plus minus 1. The trace of this is equal to this. Trace क्या है? The diagonal elements का sum करके that's how we define trace. ठीक है? And alpha can be written as, so if you want to write in terms of poly spin matrices, you can write it as sigma I 0 and beta का value आएगा 1 0 0 1. And sigma can go from, I can go from 1 to 3 है ना? इसमें आएगा कौन सा वाला first 1 0 0 1 फिर 0 iota 0 you can have 4 cross 4 matrices. You can similarly have so if these properties are there, so it says an exercise you can just prove or work out these identities and once you work with these identities this justifies कि जो उसका second order differential and first order differential they are same, and this removes the idea of negative probability. One second. 10 minutes. Now what we are going to do is 1.130. जो हमारे पास previous equation थी start में थी. So if you multiply that equation by psi dagger, so it will be iota h d psi by dt is equal to h c by iota sigma k is equal to 1 to 3 psi dagger alpha ki plus and now we can so you can you can take its conjugate. इसका हम solution conjugate लेंगे and multiplying right hand side by side. So if you do this way, So it will be like this, iota h d psi star by dt psi. So actually ये start वाली equation थी, if you remember. वहाँ alpha 1, alpha 2, alpha 3. So we've written alpha 1, alpha 2, alpha 3 in terms of alpha k. ठीक है? Plus वो last वाली term. So if we multiply this equation by this psi conjugate, इसकी जो दूसरी form आएगी, it will come out to be like this. करें काम, if alpha I, if its Hermitian conjugate alpha I is alpha dagger, beta I is equal to beta dagger. So if you subtract this from this, if you subtract this from this, so it will basically come out to be यहाँ से it will be iota h d psi by dt psi minus iota h d psi star by dt psi. So if you remember, पिछली बार the form came out to be sort of Schrödinger equation form out as an equation of continuity form out. ठीक है? So we can write it left hand side को हम we can write it in terms of psi star psi only. d by dt of psi star psi. So आप ये इसको you have done this thing. Can we write this psi star psi as this? And right hand side can be, you subtract this will subtract with this. इसको इसके साथ subtract करो, it will be plus, ये minus है, minus plus, it will be hc by iota d by dx k psi dagger alpha psi. So again, so इसका form आएगा as if we are going for equation of continuity. Equation of continuity in the sense कि जो wave function है ना, इसका value आएगा, it will come out to be d by dt is equal to del dot j is equal to this is, so it will be equivalent to d by dt of rho. So ये plus divergence of j is, we can make identification of the probability density. Identification with probability density. You can say this is basically rho is basically psi star psi. This is the probability density of the wave function which we are finding. एंड जो प्रोबेबिलिटी करंट हमारे पास है, नॉर्मली हमारे पास जो ये है इक्वेशन ऑफ कंटिन्यूटी फॉर हमारे पास आती है डेल डॉट जे इज इक्वल टू डी जे में डी, ऐसे आती है. ठीक है? सो इफ यू वांट टू मेक इट इसका इसके साथ सम सेम्बलेंस, जो जे है जे विल बी इस हिसाब से जे विल बी इक्वल टू सी बाहर है, psi dagger alpha psi. Or you can say if it's rho is psi dagger psi, this means normally d by dt of d3 of using Green's function is equal to 0. Where rho is equal to psi dagger psi. अब ये है कि नॉर्मली क्या आता है, नॉर्मली आता है विदाउट दिस इट्स इक्वल टू 1, बट वी आर टेकिंग दिस डाइवर्जेंस, इट्स डी बाई डी टी जब आएगा इट विल बी 0 रेट ऑफ उसके बाहर, इट विल सॉल्व दिस सॉर्ट ऑफ दिस इक्वेशन इन दैट सेंस. So what we have done, so I'll just end it with this thing, that so ये जो हमारे पास ये है ना, ये वाली इक्वेशन, so it anticipates probability current J4 is invariant under three-dimensional space. Rotations. And we can also show the covariance of the continuity equation. Covariance in what sense? Covariance means what? Covariance means the derivative की अगर derivative हम करेंगे एक direction में या दूसरी direction में, the quantity should not prefer one parameter. If you have a derivative along x or if you have a derivative along, they should not give different results. So this is what we have showed, the covariance of Dirac equation, but using Lorentz transformation. Because we have हमने CT को भी include किया ना. So how did we show this? जो negative probabilities को वो solution को हमने कैसे we obviated that solution by introducing this algebra, Clifford algebra जो and जो if it satisfies this algebra, alpha है ना, alpha k is alpha 1, alpha 2, alpha alphas को हमने in terms of sigma लिखा था. They satisfy this alphas and betas. Alpha and betas क्या है शाबाश? Remember they are matrices. So basically हमने यहाँ पर जो है ना alphas जो उनको हमने in terms of ये लिखा matrices, in terms of sigmas लिखा, and they are satisfying certain algebra. And doing this thing we have shown what was the main aim of today's class, was to show the invariance of covariance of Dirac equation under Lorentz transformation. This was ठीक है, the idea was this. इसमें थोड़ा सा ये है कि at your place what you are going to do, you are going to individually जो algebra को just try to prove.